Hi there. Today we're going to look at time value of money. And for intermediate financial accounting and pretty much your whole accounting career, you're going to need to own and use a financial calculator. And this allows you to do, of course, normal math, but also calculate time value of money functions, such as calculating bond prices, calculating loan amounts, calculating any future value or present value calculation. So what I've got here that you can see is the Hewlett-Packard 10B2. This is my favorite calculator, and the other alternative that has a big part of the market is the Texas Instrument. Now, I don't like the Texas Instrument because it's not very intuitive, and you actually have to learn how to use it for some of the advanced functions. And I find that the Hewlett-Packard actually takes fewer keys to do the same thing most often, and it's also much more intuitive. So my examples are going to be using the Hewlett-Packard. If you happen to own a Texas Instrument, you can certainly figure out how to do these by going online or looking at the owner's manual. Now, the one thing that you will find is that most of these time value of money functions here, number of periods, interest per year, present value, payment, and future value are the same on both calculators. So many of the examples I'm going to do here will work for the Texas Instrument as well. Okay, so to get going, let's look at how we would set up this calculator to make very few mistakes. And there are a number of ways we could do this, but what I like to do is set it up so that there is one payment per year. So that means the calculator is set for you to put in the interest rate for the period of time that you wish to calculate. So for example, if we have a bond that is a 10% annual rate and it pays interest 2 times a year, we're going to take that 10%, divide by 2 to get 5%. And if it is a 10-year bond, we're going to multiply the 10 by 2 because you receive interest 20 times. Now, at first that may seem a little complicated if you haven't used a financial calculator previously. However, I think you'll see over time that this is the best way to just not make mistakes and always get the right answer. So we're going to set this for one payment per year. So I hope you have this calculator and you can do this along with me. Now, this is just a picture. It's not going to change, but I'm going to show you with the cursor what we would do. Okay, so to set this for one payment a year, let's just clear the calculator. So you'll find that here is the second function, and underneath here it says clear all. So hit second function, hit clear all. Okay, now of course that will clear here. Now it may already say one payment per year on the screen. It'll just flash up, or it'll say 12 payments a year. So what we're going to do is we're going to hit key in 1, key in second function, and this key here in orange says payments per year. So it's the PMT key, but second function. So again, 1, second function, payments per year. Now we know that your calculator is going to consistently just use the rate that you put in. It's not going to do any division in the background. Okay, the second setting that I like to use is a floating decimal place. And that's because many rates today are not simply 2 decimals, right? If you look up some of the bank rates or mortgage rates, there's quite a string of decimals there. So you need all of the decimals, or at least, half a dozen or so sometimes. If you have your calculator set to 2 decimals, like this picture is, you could find out that maybe your rate is, let's just take this 0.04. Maybe your rate is 4.37928%. Well, you're only seeing the 0.4. That's not going to work for you. If you try and do a bond amortization table, you're going to be off thousands of dollars potentially at the end. So we're going to set our calculator for a floating decimal. So the way we're going to do this on this calculator is we're going to hit the second function here. We're going to go down and hit DISP, which is display, and then dot. Okay, so again, second function, display dot. And what that's going to do is give you a floating decimal. Now the nice thing about a floating decimal is it only puts in the decimals that are there. So unlike setting your calculator to 6 decimals, you're not always looking at a string of 6 zeros, which I actually find incredibly annoying. So for example, if you key in 5 divided by 20 equals, you're going to get 0.25, not 0.2500000 and so on. Okay, it's only going to show those zeros if you need to. So that's what we like to do to set up our calculator. I'm going to move this off, and we're going to look at some time value of money functions. Now, you're in third year accounting, so I'm hoping that you've at least been exposed to this topic before, either in an introduction to financial management class or somewhere else, but we're still going to start pretty much at the basics. So we're going to do a few examples together, and then it's going to be up to you to practice with your calculator, because you just need to be able to figure out these questions all the time, whether it's investments, zero interest notes receivable, just about anything. So let's start here. I've got the settings going. We already talked about those. Now the other thing I want to tell you about is the sign convention. And I'm going to move this picture back in. When we're calculating an interest rate using a financial calculator, some of the money you receive and some of the money you pay. If you use a positive number for all of your amounts, both cash inflow and cash outflow, it is impossible for your calculator to come up with an interest rate as an answer. So what we need to do is be very aware of money you are paying out, a cash outflow, and money you're receiving, a cash inflow. So the default is positive or an inflow, but if you're paying out money, of course, we need a minus key. But here's what we don't do. We don't just go minus, let's say, $25. We put in our $25 first, and then we hit this plus minus key here. Now again, you only have to hit this key to change it to a minus, because plus or inflow is a default. So for example, if we were going to pay out $25, then we would key in 25, and we would hit this plus minus key, and then we could use that in a time value of money function, a present value, a payment, or a future value. So the sign is very important in some problems. Some problems it doesn't matter, because all the amounts are a cash outflow, and it just will give you the right answer, and you don't even have to think about this. Okay, so let's look at a super basic problem. This is the future value of a single amount. So we're going to figure out the future value. And I'm going to do these with you as we go. And the way you can get the most out of this video is actually using your financial calculator as we do this video and do these problems. If you just watch it happen, it's not really going to do much for you. But hands-on practice cannot be beat. Okay, so we're going to clear the calculator first. And to clear the calculator, again, I'm going to move this over. Clearing the calculator is clear all. So if we're going to hit the second function and C, and that doesn't just clear the entry, that clears all. So second function, clear all. And this way, all your time value of money registers are reset to 0, which is what we want. We don't want any amounts lingering from a previous question, right? Or we'll get it wrong. So we want to know the future value of a deposit today. So the deposit today is $50,000. Now I put in a comma, but I just took it out because, of course, you're not going to key in a comma when you do this on your calculator, right? You're just going to put in 50,000, and your present value key is at the top row, third one in. So it says PV, right? So we're going to go ahead and key in 50,000 and hit your PV key. So that's how much we start with. Now we say how many years. Let's figure this out. Future value 7% interest per year, let's say in 10 years. Okay, so N is the number of interest periods. So we're going to compound this 10 times. So compound interest, of course, 50,000 times 7%, add that, and then that new amount times 7%. We're going to do that, or tell our calculator to do that 10 times. So we're going to key in a 10 and then hit N. N is the top left on your calculator. Now, interest per year is 7. Now, here's what we do. We just put in 7. We do not put in 0.07. The number you put in is assumed to be a percent. So we go 7, and then we put in interest per year. Okay, now there is no payment in this question, but I'll tell you what. If you cleared your calculator, you do not have to key in 0 for a payment because you cleared that register already. I'm going to do it anyway just in case. So 0, and I'm going to hit the payment key, PMT. Now again, if you cleared your calculator, you don't have to do that. All right, so there's only one key left here. It's the future value key. And on the Hewlett-Packard, what's going to happen is when you hit the future value key, it gives you the answer. It's how much money you will have 10 years later at 7%. If you are using the Texas Instrument, there's a compute key, CPT, at the top left. And of course, you have to use that key first and then hit future value. But I'm just going to hit future value now. And what I get is 98,357.57. And of course, this is money, so we can't have a string of decimals, and we can't call it 0.6, because even though we don't have pennies in circulation, we still have pennies in terms of the banking system, right? So that rounds off to 57 cents. So there's our first problem. Lots of money. Let's look at the future value now of an annuity. So the idea of an annuity is that there is a yearly deposit of money. So deposits are assumed to be made at the end of the year. So we're going to deposit $6,000 per year for 10 years and earn 8%. So let's clear the calculator. So second function and clear, and you will have cleared your calculator. Now our present value is 0. And again, you should not have to put this in because you cleared your calculator. If you forgot, it doesn't hurt. You put a 0 in, and we're saying essentially we're starting with nothing today. Now, we're going to be doing this deposit for 10 years. So we're going to put in 10, and we're going to hit the N key. That says number of payments. That's us paying. Our interest is 8%, and remember the percent is a given. We're just going to put in 8 and hit your interest per year key. And then we're going to key in 6,000, and that's our payment. Now, if you think about it, we just put in 10 payments of 6,000. So the future value, the amount we have at the end of 10 years, better be more than 60,000. You know, if it's not, we made a mistake. But again, we just need to hit the future value key. And here's what I get. I get 89,919. Now I've rounded that off to the nearest dollar because we don't need pennies or to worry about pennies. But so this is rounded off to the nearest dollar. So this is how much we would have in 10 years. Okay, let's look at the present value instead of the future value. So we're saying what is the money worth today. So if you took that amount and you put it in the bank for, in this example, 15 years, this is how much you would have. You would have 100. So we're looking for the equivalent amount today. So our interest rate is 5% in this example. We're going to receive 100,000 in 15 years. So we're saying what single amount would we need to put into the bank today in order to have a balance of 100,000 in 15 years. So let's clear our calculator. I've just done that. Now, the future value, the amount I want in the future, there's 100,000. So key in your 100,000 and hit future value. 15 payments. So 15, and hit your N key. Interest per year is 5%. So we're going to key in a 5 and hit interest per year. Now there is no payment. And again, if you cleared your calculator, you don't have to use the payment key. So I'm just going to try it this time without it. I'm going to go no payment. I'll just leave it empty. And I'm going to hit PV. And that PV key should give me the single amount today that we need to put in. And I get 48,102 rounded to the nearest dollar. Now just for fun, I'm going to put in 0 PMT. I'm going to hit PV again. So it goes 0 PMT, hit PV again. We still have the same number, right? So if you've cleared your calculator properly, you don't have to worry about hitting every key and filling that in. So we didn't have to do that, right? Now, just as we looked before at the future value of an annuity, which is a constant payment, by the way, we can look at the present value of an annuity. So this time, we're not saying, oh, we're going to get $100,000 in 15 years or something. We're saying, okay, we're going to get $10,000 a year. So let's assume that we could earn 5% on our money. We're going to get $10,000 a year for 15 years. What's that worth today? So clear your calculator. And there is no future value here because there is only a payment. So make sure you don't put any number in for future value. And because we cleared the calculator, I'm just going to leave this empty. We know we're talking 15 compounding periods or 15 payments. So put in 15, hit N. Our interest per year is 5. So we want to go 5 is interest per year. Our payment amount, 10,000. So there's 10,000 for a payment. And what would that be worth today? So we're going to hit PV. We get 103,797. Okay, so in theory, this would be your amount at which you are indifferent. You could say, well, I could get 15 payments of $10,000, or I could get 103 and change today, all the same to you, because of course, if you, let's look at this backwards. If you deposited this much today, you could take it out of the bank at $10,000 per year for 15 years, earning 5%, and at the end of 15 years have nothing left. Okay, so lots of uses, both personally and in business for this. For example, depending how old you are or your parents are, they might be looking at a registered retirement income fund. Say, how much, this is what I have saved in my RRSP, how much can I take out over the next 15 years? Or what if I want to stretch it to 20 years? Well, I'll tell you what, we could do that too, right? And figure out what we would need. So once you have those numbers in your calculator, if you haven't cleared your calculator, they're all sitting there in the register, you can play around with this money. So for example, what if we only were to receive 8,000? So let's try this. Let's key in 8,000 for the payment. Now we're not talking about a $10,000 payment, we're talking about an 8,000 payment. And if I hit present value again, I get 83,037 dollars, right? So of course, a smaller amount because the payment went down. So once these numbers are sitting in your calculator, you don't have to re-key in everything to do sort of a what-if calculation. Okay, now you might be wondering how long this video is going to go. I've got a few more slides here and a few more examples. So this one is tricky. We want to calculate the rate. Now, some sort of purists will say, oh, we shouldn't use a financial calculator, we shouldn't use Excel, we should just do everything with a formula. So these are generally people who really like math, But I'll tell you what, if you're doing accounting, you're not being paid to take longer to do a problem than it needs, okay? So we don't, like if you're doing an accounting, you're not using formulas. You're using Excel to do this, because of course all these functions are on Excel, or you're using a financial calculator or maybe a built-in program if you're at a bank, and they'll actually have a piece of software that you use for this. But basically, we're not going to use formulas because they take longer. You know, you've heard time is money. Well, I'm not going to waste time doing math when I don't have to. But here's an interesting thing that comes up. There is no formula to calculate the rate. The only way you can use a formula to calculate the rate is to pick a rate at random, take your best guess, and try it with the numbers and see how you did. If you don't have enough, you can try a different rate. So you could be at this for, an hour trying to figure out the rate. But we can do this with our calculator or on Excel in like 30 seconds, right? So what we're going to be doing to calculate the rate is we're going to be putting in, this actually is a rate. What I'm going to try and calculate is the interest per year. So what we need are these figures. So if there is a payment, we put it in. We put in the future value, we put in the present value, and we put in the number of periods. Now what's going to happen then is your calculator is going through all the things that you would do, trying a rate, adding, trying another one, subtracting, and it just does it, of course, really fast. So let's do, we better do a question here. I don't even have a question for you, so let's just make a question. Okay, so great. I paused the video and I put in a question. So I hope you remember bonds from your introduction to financial accounting class, because we're going to do lots of them in intermediate anyway. So here we have a 10-year bond. It pays 8%, and of course that's the coupon rate. That's always the annual rate. It pays interest 2 times a year, and it's issued for $95,000. So what we want to know is, well, what was the market or yield rate? So we're going to clear the calculator, but first let's make sure we know what's going on. 10-year bond, but it pays interest 2 times a year. So that means there are 20 interest periods. So down here, we're going to have 20. Now, the coupon rate is 8%, but that's an annual rate. So we have to divide this by 2, or 4. We get 4%, and it pays 4%. Now, I didn't even write the amount of this bond. It's issued for $95, so I'll just tell you. I'll just write it in here. So the face amount is $100,000. Okay, so you will receive, or the investor will receive, $100,000 when the bond matures, but it's only issued for $95. So it was issued at a discount, which means the market required a higher interest rate than the bond pays. And we'll be looking at this in a little more detail, but right now we're just kind of looking at how to do this on your financial calculator. So there are 20 payments. The interest rate for 6 months that the investor receives in cash is 4% of the $100,000. So we're going to calculate that. Now notice that as a bond issuer, you owe the money. You pay $100,000. You also pay interest 2 times a year. Those are both cash outflows. The present value, or the issue price of $95,000, was a cash inflow. So this is one of those tricky questions. I mean, once you see how to do this, I think it'll be easy for you. But the first time you do it, we have to pay a lot of attention, because an outflow of cash, we need to use that plus minus key to make it a minus amount, whereas the inflow, the $95,000 we get to begin with, is already by default a positive amount. So I'm going to show you how to do this fast on your calculator. Okay, so let me just adjust this a little bit. I'm about to show you how to price a bond really quickly. Now, we actually have the price, but just the same, let's look at how to do this. So, sorry that's jumping around so much. So 100,000 is the future value. So key in, well, clear your calculator, key in 100,000 and hit the future value key. Okay, so I just did that. Now, the 100,000 is still showing on your screen. So here's what I do. I just go times 0.04, and then I hit the equal key. So if you go times 0.04 equals, you're looking at the payment right on your calculator. This is what your calculator says. It's showing 4,000. So once that 4,000 is on the screen, you just have to hit payment. Okay, so I'm going to hit payment. Now, I'll tell you what I did. I put in both of these numbers as a positive amount. But of course, they're outflows. So not to confuse you, but as long as you can do it backwards. It doesn't matter. If I put these two amounts as an inflow or positive, then I need to put in this amount as a negative, and then it'll work. Or alternately, we could start over. We could put these in as a negative and this in as a positive. Now I started with these as a positive, so I'm going to make sure that my 95 is a negative. So we have 20 interest periods, so I'm going to go 20 and hit N. And then I'm going to key in 95,000. And then we're going to hit that little plus minus button. That makes it an outflow. And then we're going to hit present value. Now, as soon as you hit interest per year, your calculator is going to calculate the market rate or yield on this bond. And what we have is 4.380408. Now what I want you to note that is that we told the calculator there are 20 interest payments. Therefore, this is the rate for half a year, not a full year. So we're going to multiply that by 2, and that's going to give us the annual rate, which I'm going to kind of round off here for you, 8.7608. Okay, so that's what you should have on your calculator. Now, I know we could turn into a long video here, but I think it would be worthwhile to do this question again, but simply backwards. Let's do this. And let's put in these numbers with the $4,000 payment and the $100,000 at the end as an outflow. Okay, so if you clear your calculator, key in 100,000 and hit the plus minus key, now that says to your calculator this is a cash outflow, then hit your future value key. Okay, so that's our future value. And just like before, we want to know what the payment is, and we know that it's 8% per year. So we're going to go times 8%, well, 0.08, divided by 2, and we know then that that rate is going to be 4% per half year. Okay, so 100,000 times 4% is going to give us $4,000. So with that $4,000, what we want to do is make sure that that is showing up on your calculator as a minus. And that will happen if you hit that plus minus key. So look at your 4,000 and make sure that that is a minus as well. And then this is an outflow, this is an outflow. So we're going to have a 4,000 outflow, we're going to hit payment, and then just like before, we can hit 20 for N, and this time our 95,000 is a cash inflow, so just 95,000, hit your present value key, and when you go to hit your interest per year key, you get that same number that we had here, the 4.38, and so on. Okay, so you've got the same number showing as before. So we could actually do this in any order. Okay, now let's look at, before we finish up, let's just look at a few other little things here. So your calculator has cash flow keys. And the cash flow key, I'm just going to show you where it is. Cash flow key is right here, CFJ. The J is the number of the cash flow starting at 0. If we want to, and we have a set of cash flows, like from a project we're going to start, we can calculate the net present value if we have a rate, or if we're not given a rate, we can calculate the internal rate of return. So remember, cash flow is what we're thinking about. A cash flow is either an outflow or an inflow. Most of our projects are going to begin with a cash outflow, and as we start to earn revenue and make profit, our future years will be a cash inflow. Okay, so let's look at this example. We're going to say that we need 11% in order to take on this project. If we don't get 11%, we're not going to do it. Okay, so when we finally finish up, just so you know, when we finally finish this, if our NPV, net present value, is more than 0, then we are earning 11% or more. If it's less than 0, a negative, we're not earning 11%. So our initial investment is 10,000. We're going to earn a profit of 2,000 in year 1, a couple of years at 3,000, a couple of years at 4,000, and then in year 6 we get 6,000. So first thing we're going to do is we're going to clear the calculator. I didn't write it there, but please clear your calculator. And we're going to put in 11 and hit your interest per year key. Okay, so that tells the calculator do this at 11%. Now, the first number we have is the 10,000 outflow. So I'm going to make sure I hit that plus minus key to turn that into a negative number for a cash outflow. So you do that, and then you hit your cash flow key. So watch what happens when you hit your cash flow key. It flashes CF0. So that told you that's today's amount. Now, let's do year 1. We're going to put in year 1. This is an inflow. And then we're going to hit our cash flow key again, CFJ. Okay, so key in 2000, hit your cash flow key, and it momentarily displays CF1. So that's at the end of the first year. Now on this calculator, putting in a duplicate cash flow, there's a couple of ways, but a really easy way is just to hit the cash flow key 2 times in a row. So what you see here is that our inflow for 2 years in a row is 3,000. So we're just going to hit 3,000, key in 3,000, hit cash flow once, hit it again, and that flashed up cash flow 3. Same thing for years 4 and 5. We're getting $4,000. So key in 4,000, hit your cash flow key 2 times. It flashed CF5. Now in year 6 we get 6,000. So we're going to key in 6,000 and hit cash flow. So we've put in all our cash flows. Sorry. Now here's what we need to do. We need to calculate the net present value. And if you look on your calculator, I'm going to show you, sorry. Right here, this key second function says NPV. So right there is our net present value. That's the key we're going to use with our second function. So key second function and key net present value. And you're going to get 4,647 when I round that off. Now, just for interest, something you can do is you can say, well, what interest rate is that? There's an internal rate of return key, and let's look at where that is. Right here is internal rate of return. So while all of that information is in your calculator register, you can hit second function IRR. And if you do that, it's going to give you 23.43%. So this is second function IRR, well, 1R, and it comes out at 23.43. Okay, so that's the return on this investment, and it makes sense, right? It's over 6 years, but if you look at the total cash flow, we've got 22,000 total cash flow coming in over 6 years, right? So we're doing pretty well with an investment of 10,000. Okay, now we just sort of did this on the previous slide, but if you wanted to start with internal rate of return, you would do this. Okay, so I've got a slightly different example. I've got an initial cash outflow of 20,000, and these are 4 cash inflows over 4 years. Okay, and we're not starting with a rate, we just want to know what is that rate. And again, you cannot do this with a formula. So let's start with 20,000. Now this is an outflow, so we're going to hit our plus minus key. It's going to make that a negative, and then we're going to hit cash flow. And when you do that, CF0 shows up. Then we're going to hit 6,000, key in 6,000. Your cash flow key. Similarly for 5,000, hit your cash flow key. I don't know why it's doing that. 7,000. And finally 9,000. Okay, so I have to catch up here because I haven't put any of these numbers in. So I'm going to clear my calculator, put in my 20,000 as an outflow, my 6,000, my 5,000, the 7, and the 9. So that's at cash flow 4. Now we're going to go second function IRR. So second function IRR, and your calculator should be showing 12.099. Okay, so we've got 12.099% return on this project. You know, and your corporation might have a limit. They might say, you know what, we have to make 10% or we're not going to start a project. So now you know you're making 12. You could also put in a rate and calculate the present value. Okay, so last example today, let's use our calculator to price a bond. So we have a 10-year bond that has a face amount of 100,000, coupon rate of 6%, it pays interest 2 times a year, and the market rate is 7. Okay, so whenever the market needs more than you pay, the bond is going to sell at a discount. So right away, we know that the present value or issue price is less than 100. Now let's do this. So let's start with clear the calculator. And and it should flash one payment per year when you do this, by the way. Okay, so 100,000 is the future value, so key in your 100, hit future value. Now we're going to figure out what the payment is. We're going to go, your calculator is showing 100,000 on the screen. So if you just hit times 0.03 equals, I'm going to do that, it's showing 3,000. Now I'm sure you could have done that in your head, but it's not always a nice easy 100,000. So your calculator is showing 3,000 right now. So that's already on your screen. All you need to do is hit payment. Now we put in the future value, we put in the payment. The 10-year bond with 2 interest periods a year is 20 interest periods. So key in 20, hit N for number of periods, and the market rate is 7%, but we have to divide that by 2 because it pays twice a year again. So we're going to have to use 3.5. So again, you don't have to convert this to a decimal, just put in 3.5, hit your interest per year key, and now when you hit your PV key, you'll get the issue price of the bond. And as predicted, it's less than 100. So there's our bond issue price. So I'm sorry that was such a long video, but of course you can skip through to the part you want or watch the whole thing, whatever you like. But hopefully this gives you a good idea of time value of money and using your financial calculator.